I'm Dr. Stella Chou. I'm a pediatric hematologist and transfusion medicine specialist at the Children's Hospital of Philadelphia.
Dr. Chou and colleagues presented their findings on the innovative use of induced pluripotent stem cells to help identify complex RBC antibodies.
The main focus of my research has been to improve transfusion therapy for patients with sickle cell disease. These are patients who oftentimes require chronic transfusions on a monthly basis, and they oftentimes make antibodies to the transfused red cells, which then poses a problem for us in terms of finding donors that are a good match for them, that can provide a safe transfusion, and then also ultimately give us the outcome that we want, which is to treat their underlying disease. So it started out as more of a genetic project where I worked with Dr. Connie Westhoff at the New York Blood Center, and we basically revealed that patients with sickle cell disease have tremendous diversity in the Rh gene. And this has been now recognized as a risk factor for them making antibodies against transfused red cells because their Rh proteins are mismatched to those of the donors. On a parallel project, I had been working on hematopoiesis and using induced pluripotent stem cells to study certain pediatric blood disorders. And it was an idea that came up a few years ago to basically take that technology plus the technology of CRISPR-Cas9 gene editing, which had just appeared, and to generate customized induced pluripotent stem cells from which we could make a renewable red cell source. Right now we rely on donor-derived red cells, which are basically commercialized and phenotyped, but what's lacking for patients with sickle cell disease are some very rare or uncommon donor types that we require for really specifically finding what their antibody is directed at. And it was our idea to basically manipulate iPS cells so that we could have a renewable source of cells to make red cells as reagents to be used in the local blood bank. I have some wonderful colleagues and collaborators. I've been trained in transfusion medicine and then also iPS technology that basically brought all this expertise together to, in a nutshell, do something actually pretty simple, ultimately, that could really make a difference for these patients in terms of getting the right blood quickly. There's a big impetus to really improve the care of patients with sickle cell disease. While it's a rare disease in the United States, it's not a rare disease worldwide. I think one of the exciting things about this project is that this is something that can go to developing countries. I recognize that blood transfusion is a big challenge for patients in other countries that are not as developed as the United States, and potentially this is a technology that we can transfer there. In that process of developing this assay, we're improving how we differentiate red blood cells to mature red blood cells, and the Rh null cells that we're going to make are essentially a universal donor, so could pretty much be used as red cells out in the field. It could be used in emergency rooms as emergent transfusions in ICUs and the ORs. So it's also something that we think in the future will go beyond sickle cell disease and just go to patients who require rapid transfusion. I think the next step will be streamlining the production of these red cells. So for us, it started out as an academic mission, but also to help patients. But I think that in order to produce them in a way that is under GMP facilities and likely having to have certain FDA regulations, we'll need to work with industry to ultimately bring a product to the shelf. It's a really exciting time for patients with sickle cell disease. There are many new discoveries and many different avenues that people have taken to either come up with new diagnostics, new therapeutics, and overall, I think that ASH has been a big supporter of investigators such as myself and for people who are interested in advancing the care of sickle cell disease.